Alrighty. This is Calculus 1, Uno. 3.4 derivatives of logarithmic functions. Now, these things right here have their own special rules. If you guys have those flashcards, there's a couple more flashcards that you're going to use because of this. Okay, do you guys still have flashcards?
Yeah.
Did you guys, anyone actually cut the flashcards out yet? No.
Easier to read them from the
Okay, so what are you going to do tomorrow during homework time too, right?
Homework.
Yeah, besides homework.
Nothing.
Okay, how about advisory? Since you're not going to be doing any traveling, you're going to sit in your advisory and...
I need to read books. It's time for
Anyway. Alright, so I'm going to pretend like you guys are just going to like do what you're supposed to be doing, okay?
What's that?
Staying off your phone, that's what it is. Yeah, I see you right there. You're right, I don't, because, no. It's that other person with the phone that, right next to her calculator, like I can't see it.
Plain cool.
It's right here.
Okay.
It's not open.
Anyway, alright. Differentiating logarithmic functions. Recall the following statements are equivalent. So, whenever you could actually take a log and turn it into an exponential. Okay? This is helpful. This is algebra. Okay? This, if you don't know this one off the top of your head, then, you know what, circle it, highlight it, tattoo it on your arm as you need be. Okay? I've seen a couple people actually tattoo the quadratic formula. And I'm like, okay, yeah, you really need the quadratic formula that bad that you would tattoo it?
There is a student teacher who did that.
I know, but like quadratic formula is like, okay, let's it's something basic. It's like putting y equals mx plus b on your arm, or tattooing that. I've seen plenty of people. Should be like basic. So you guys should use like the unit circle or something tattooed. That would be a little bit more, helpful, I think, right?
Yeah.
Isn't it cheating on exams?
If it's a tattoo,
They're like, no, you're not going.
I don't know. Like seriously, I don't think I've ever run across that problem.
I think they can just like take the hand or something.
I know, right? Because you're like, oh yeah, no, blah blah. Nope, that's my tattoo. Yeah. Anyway, but still,
Easy.
I'm not gonna say that there would be extra credit for someone to actually do that, but I would give you a crisp high five. If you would be that dedicated. Okay.
Oh, that's kind of helped me through college. That's what I'm gonna do.
Huh? Unit circle right here on the forearm.
Exactly.
No, thug life right there. Okay.
On the car.
Okay, so anyway, these are important. They are going to be very, very helpful. And I'm going to show you guys a little bit more algebra later on that goes along with the change of base. Let's take a look here. All right, so the derivative of log A, so my base is A in this one, of x, is going to be 1 over x ln A. And x has to be greater than 0. It can't be equal to 0 because that would give me 0 in the denominator. Okay? Alright, so does that make sense? So that's my log. This is actually one of the flashcards that you guys have. And here's another flashcard right here. So the derivative of ln x is 1 over x. It's 1 over whatever my x values are. Okay, we're going to apply some more chain rule to this to make it a little bit more complicated. Hey, let's do that. All right, so before we get too carried away, I want to jump straight to B. Because that was just on that last slide, wasn't it? Say yes. Okay, so all right. So for this one right here, if it's log and it doesn't say any base at all, what is the base? Excellent. It is 10.
Isn't it ln?
No, ln is e. ln is log base e. Okay? So in this case, right here, my base is 10. So technically, this would be 1/2 log base 10 of x. Right? So, given that much information right there, how would I rewrite this?
1/2 divided.
It's
like 1 divided by 2.
okay, so it's 1/2, right? So it's 1/2
multiplied
times 1 over x ln of
10.
10. Okay. Alright. Don't let me forget to pass these things out. Is that too bad? Okay. Questions? Because we're just pulling that straight off of the formula there. Alright.
What's the answer?
That's it? That's what I'm saying. Alright, now let's go back. So let's do D now.
Why not C?
What's this too?
Hmm?
Why not C?
No, because I'm going to come back to it because we're doing the logs right now. I'll do the ln's next. Okay? Because if I go on the previous slide, logs were first, then ln. Okay? So what is my base of D?
2.
It's 2, right? Okay, and this has a 10. There we go. Okay, and that one right there. So I know I'm going to have to deal with that cube, right? So to deal with that cube, what am I going to do with that?
Find the derivative.
That is a rule to go along with it.
Change
Nope. If there's an exponent, what can I do with that exponent? It goes with ln's and it goes with logs also.
I don't speak English.
You don't speak English?
Isn't it like 3x
Okay.
squared?
No, right here. When there's an exponent here, because the log rules that go along with this number, this cube, could be moved out front.
Yeah, right.
So this is going to be 3 log base 2 of x. Now, does this look a little bit better? Okay, so now we can go ahead and do this, right? So I would write this as what?
3 times
3
times 1 over
1 over
x ln 2.
x l n 2.
I was right.
Yeah. So where was that 3 going? Three goes on top, right? Alright, so we did that one now. So that helped us out. So now I can go back up to 1. So that square, what am I going to do with that square on 1? Or not 1, a.
Oh, it's going to go.
Where's it going? To ln x. And what was the rule for the ln's?
1 over x.
1 over x, right? So take the derivative now. It's going to give me what?
2 over x.
2 over x. Not bad, right? Not bad. Let's take a look at the next one. So derivative of ln x would be
1 over x.
1 over x. plus, what's the derivative of ln y?
dy dx over y, multiplied by 1 over y,
1 over y
and
dy dx equals
2.
2. Are we okay here? That step right there is actually going to be helpful for a lot of the things that we're going to do, because we're going to solve some crazy stuff here in a little bit. Alright, so given that information right there, I'm trying to get, to do the derivative, I need to get the dy dx by itself, right? So I'm going to do some algebra, right? I'm going to do some algebra, so I'm going to move this to the other side. Let me clear off what I already have down here so I can make some room. Alright, so algebra says I'm going to have 1 over y dy dx equals 2 minus 1 over x, right? Because I'm going to subtract the 1 over x from both sides.
And then we need to make the same with the main.
Okay, so what am I going to do to get the y to the other side? Multiply both sides by y, right? So I'm going to get dy dx equals y quantity 2 minus 1 over x. Yep. That's it. That's an implicit right now. If I went through and solved for y, then I could go through and actually like get that by itself, so I could have this only in terms of x's, but it's not necessary. Make sense? Okay. Alright, so chain rule for this. So it's the derivative of the inside times derivative of the outside.
Why there's no chain rule for log?
It's the same thing.
Yeah, but like,
It's the same thing.
but if it's not
It's the same thing.
log,
It's the same thing.
even if the log has the.
It's the same thing. Do you know why?
Like.
Do you know why?
Why?
Isn't log e, it's log base e,
Yeah, but.
is the difference in between
But if
L.
it's going not to be a base e, if it's going to be a base some number.
Okay, then we do it the exact same way as we did earlier.
Oh, right.
Derivative of the inside times derivative of the outside.
Okay. So what's the chain rule for logarithm?
Huh?
What's the chain rule for logarithm?
Oh, same thing. Derivative of the inside times the outside.
Yeah, but.
It's the same thing. Well, do you want me to find you one?
It was a joke, so.
Oh, yeah. Yeah, don't be a bow today. Can't handle that. What's the derivative of the inside? 5 times. What's the derivative of the outside?
1 over 5
Which gives me just
1 over 1 over
1 over x, because
Because fives
5's
cancel out.
cancel out.
Why do we need the previous rule then if it's the same chain rule? Why do we need that? It's the same thing.
I don't know. I don't know what you're talking about.
No, like.
Please speak English. I really,
the
you know what?
previous slide, why did we
I
need
don't
it?
understand what you're saying, seriously.
Why did we
You
need
really need to stop mumbling, because I have no clue what you're
It's
saying.
too much.
Alright, so now for this one right here, isn't this product? Say yes.
Yeah.
It is product because it's x times ln of all that, right? So it's a product with the chain. So if this is f, this is g. F prime would be 1, g prime, so the derivative of all of this is a chain rule, right? So the chain rule, what's the derivative of the inside?
2x.
So it's 2x times the derivative of the outside, which would be it decided to stop working again.
No, it should work. I guess.
There we go. Alright, 1 over x squared plus 1. Right? So we have all that. So now let's do the product rule off of it. So it's going to be f prime g. So it's going to equal ln of x squared plus 1 plus g prime f, right?
Yeah.
So g prime f. So f is x, right? So x times 2x over x squared plus 1.
That's it.
Yeah?
Yeah.
Okay, so now from right here, this next part is going to be, just cleaning it up, ln of x squared plus 1 plus x, 2x squared over x squared plus 1. Alright, need some room for this next one. Alright, so this next one, y equals ln of x, absolute value, right? So we know that because of this, we're going to have different parts. We're going to have different parts of this right here. Because on this part right here, absolute value. Absolute value. So I could plug in numbers, but I'm going to be using absolute value. And so there's going to be a little bit of restrictions on either side. Now, where is this? I'm trying to say it right. What's the domain of ln x?
X more than 0.
More than 0. Anything else? Okay, watch this. I'm going to show you guys on the graph at least. There you go. All right. So I have ln of absolute value of x. There we go. So there's the absolute value of that. So now, can we take a derivative at 0? Say no. We cannot take a derivative at 0. But because that absolute value there is going to always make it positive, because my normal ln x without the absolute value is going to look like this. It's only this side right here, because it is undefined on the other side. So it would be from 0, it'd be parentheses from 0 to infinity, it would be my domain. Okay, because of this I can't have anything at 0. But because I am doing the absolute value here, I am allowed to actually have this on both sides now. So I do get a derivative here, I cannot take a derivative at this point. This point right here would be 0, right? Because if I'm looking at this, what's the derivative of ln x?
1 over 8.
Am I allowed to have 0?
Mm-mm.
No. The derivative would be undefined, so I cannot take a derivative at that point. That's what I'm trying to get to. So I am allowed to have a derivative, but at all points except for 0, because 0 would be one of my critical numbers here. Does that make sense, or did I just confuse the crap out of everyone?
No, no, it's good. Makes sense.
Confusing?
No. Mm-mm.
Did the graph help you out?
Mm-mm.
Okay. All right. Trying at least. Okay. All right. There we go. So can't be 0. And guess what? I'm gonna leave you guys with that today.
Cool, cool.
So tomorrow we're gonna pick up. Actually, no. Tomorrow's gonna be Wednesday. All right. Like, subscribe.